let's look at the questions we have for the circles. So first one is write the standard equation of a circle with the given center that passes through the given point. So first of all, I like to draw a circle. So as you see, draw a circle. So first find the center. Center is here. C. Just put a C here. It's say -3 and 5. Okay. So then there's a point, 2 and 7. So just the point is goes through this circle. So the point is P at 2, 7. So then we know that between the C and the point, if we connect it together, it is radius r. We know the center, but we still want to know the radius. So the radius is r equal to square root as 2 minus -3 square plus 7 minus 5 square. So -3 and 2 and minus -3 is square root 5 square plus then 7 minus 5 is 2 square. So that is square root 25 plus 4, it is square root 29. So we just leave the square root 29 there because ultimately we want r square. So based on that, we have the equations, that standard equation of circle is x minus -3, that's the center of x, plus y minus 5 square. That is r square. Here, remember r square. So our r square here is square root 29 parenthesis square. So it is, because the square root and the square can cancel each other, so it is 29. Remember, 29 is r square. Okay. So eventually we just tidy it. Then this is x plus 3 parenthesis square plus y minus 5 parenthesis square. That equals to 29. So that is the standard equation of a circle. Okay. Now we go to the next section. This is about the quadrilateral, then it's inscribed into a circle. And we know that the quadrilateral, all four vertex, the angle added together, interior angle is 360 degrees. So first of all, we look at the condition of the question, and we just mark it here. So angle T is 110 degrees. Okay, we just mark it here. Then angle Q is 75. Okay, 75 angle. And we know that the angle, the whole circle is 360 degrees. Then because it's an inscribed circle, so across the angle for the quadrilateral, like angle Q plus angle S should be 180 degrees. So based on that, then angle S is 180 degrees, subtract 75 degrees, so it is 105 degree. Okay. Same reason, then because this is the arc of QRS and arc of QTS. They add together arc should be 360 degree, but the interior angle, inscribed angle, they add together should be 180 degree, half of the total circle. So then we have angle R plus angle T is 180 degree. Then angle R should be 180 degree subtract 110 degree. So angle R is 70 degree. Okay, so that's how eventually we just should have here. This is the angle S here, and this is angle R here. Okay. Oh, yeah. So here that's the second part of our practice. Okay. Now the third one is about the area of the sector. So QRS, because originally the question doesn't give you the drawing. So when you say the circle is R, so find the center here and put R here. So this is the circle R. And given information, leave there certain in terms of pi. So we know that QS, the sector of QRS, so QRR is the center, so Q is, let's just draw it here, RS is kind of like a 160 degrees, so it's quite not to the semicircle, but it is the almost to the semicircle. So this is excuse me, here should be QRS. So that's the area we want to know. It's the section. Okay, so the radius is 5. So when we want to calculate the area of the sector, so we know that this is 160 degree, so area should be 160. But compare with the whole circle, 360 degree. That's the full circle. Okay, basically it's like that. Then time, the whole circle, the area should be pi r squared. Right now, R is 5. So we have 160 over 360 pi times 5 square. Don't forget this square. Okay. So once we have that, we just simplify it. Then this is 0, 0. We cancel each other. Also 16 is 4, then this is 9 pi 9, not 5, 9 pi time 25. So eventually it is 4 times, we just leave pi there, 4 times 25 is 100 divided by 9. So that's the answer. So this area is 100 over 9 pi. Okay. All right. So the last one the fourth section is about write the standard equation of a circle. So the condition is we want to know the standard equation of the circle is first we want to know the center. So here the center is, just we look at the graph, center should be -2 and 1. So it's -2 and 1. Then radius, we just count here. The radius is 1, 2, 3, 4, 5 from the circle to the center. So r equals to 5. So once we have that, then we can write it into the standard equation is x minus -2 square plus y minus 1 square is 5 square. Don't forget this square. Basically, it's the derived from the distance equation. Okay. So we just combine it together. X minus -2 should be x plus 2 square plus y minus 1 parenthesis square. 5 square is 25. Okay, so that is the standard equation of the circle we need to write. Okay, so that's all for this part of our PMA review for the circles.